Okay, here we go with a gravitational fields question. We're asked to determine the possible values of n and m for the relationship between t and r of a planet's orbit. Love this question. You might not, but as ever, hit pause, give it a go, and then we'll press play. Okay, so this is really a test of one of Kepler's laws. Okay, and what I'm going to do is I'm going to derive it and then we'll look at the answer. We're going to start off by the fact that when we're looking at an orbit, we've got the relationship between the gravitational force and the centripetal force. What we say is the gravitational force provides the centripetal force. Now I've written the centripetal force in this version. We've got m omega squared r. There's another equation, mv squared over r. Both are relevant. However, I think this one's easier for the manipulation I'm going to do here. Okay? We're going to work through this to try and get a relationship between t and r. Firstly, we're going to cancel the m's because they are multiplying on both sides. And you'll notice here we've got an r and an r squared here. Okay, we're also going to substitute in now for omega to get that dependence on t. We've got 2 pi over t all squared. And then we're just going to work it through to end up with a relationship which is t squared equal to 4 pi squared over gm r cubed. Now you'll notice here we've got n, which is our power of t, and m, which is our power of r. I've used a small case r, my apologies here. You notice I've got, for example, I've got n here equal to 1 or 2. Okay, but then 2 goes with 1.5, doesn't work. We're expecting a 2 and a 3 here, that doesn't work. Okay, we've got a 1 and a 1.5. So we're not really sure what the answer here is. However, what we can do is we can start ruling out some answers. We don't have a 2 and a 1 here. Okay, and we don't have a 2 and a 1.5. However, what we can hopefully see is that we can take the square root of these things. Okay, we need n to be equal to 1. That's the only possible answer. We're going to take the square root of this. We get a big constant at the front, and the important bit is r. R to the 3 square rooted gives me r to the 3 over 2. Well, 3 over 2 is 1.5, which means the answer here is B. Now, the reason I've gone through this derivation is it's a classic question, not just from multiple choice, but from paper 2, where you might be asked to prove a relationship. And the way that we start with this is always to equate the centripetal force to the gravitational force.